So now we need to discuss implicit function. Okay, so sometimes it is difficult to separate the variable x from y. So all the functions that we have been working with since are explicit functions because we can easily separate the variable y from x. Okay, but if it is difficult for us to separate the variable y from x, then we have what we call the implicit function. So let's take an example of an implicit function and how we find the derivative of implicit function. Okay. So whenever we have a function like this, so how do we find the derivative? We differentiate term by term. Okay. So we differentiate x squared. What will x squared give us? 2x. Beautiful. Okay. Plus whenever we have the product of x and y. Okay. So we apply product rule. Okay. So recall the product rule. We take the first as u, take the second as v. Okay. So don't forget our product rule. Keep u, that is x. Differentiate v, that will give you 1 abi, and then you add what the x is the y, right? Okay, then keep v plus keep v, which is y, then differentiate u, that is x abi, differentiating x, that gives us what 1. Okay, so that's the derivative of this one. Then plus, then we now differentiate this, we're going to have 2y abi, but because it's the y that we are differentiating, you had what the y the x. Okay, this is equals to derivative of constant 0. Okay. So what we now do is we collect like terms. Those with dy dx, we put them together, and those without dy dx, we send them to the other side all together. So we have x dy dx plus 2 dy dx. We send the other one to the other side so that we have minus 2x minus y. Then factorize dy dx so that we have dy dx open bracket x plus 2y is equals to minus 2x minus y. Then divide both sides by x plus 2y, the coefficient of dy dx, so that we only have dy dx is equal to minus 2x minus y over x plus 2y. And that is the derivative of that function. So now, let's look at another example on implicit function. Again, don't forget we differentiate term by term. So differentiating x cubed, we're going to have 3x squared. Differentiate y cubed, we have 3y squared. But whenever we differentiate that, we have what? Dy dx plus this we apply product rule. Okay? When we apply product rule here, we make 3x u and then y squared v. So keep u, differentiate v, we're going to have 2y dy dx. Then keep v and differentiate u. That will just give us 3. Have you? Okay? Because we make 3x are what? U. Okay? This will now be equal to 0. So the next thing is just to simplify. So we have 3x squared plus 3y squared dy dx. Then this will give us 6, 2 times 3, 6, xy, and then we have dy dx. Then here we have 3y squared equals 0. So then we can collect like terms. If we collect like terms, we're going to have 3y squared plus 6xy dy dx is equals to move 3x squared to the other side as well as 3y squared. So that we have minus 3x squared minus 3y squared. Then we can divide both sides by the coefficient of dy dx. So dy dx will be equals to minus 3x squared minus 3y squared divided by 3y squared plus 6xy. Now, something is common. You can't leave your answer this way. Something is common to denominator and denominator. And what is that? 3 is common. 3 is common. So we can factor out 3. So that we have 3 open brackets minus x squared minus y squared. Okay? Divided by 3, we have y squared plus 2xy. Okay? So just take care of this. And then we have the y dx to be equals to minus x squared minus y squared over y squared plus 2xy. Now, let's see a shortcut to finding the derivative of implicit function. Okay, so write the function as x cubed plus y x cubed plus y cubed plus 3x y squared minus 8 equals 0. Okay, so meaning that we have a function of x and y, which is this s cubed plus y cubed plus 3xy squared minus 8. Okay, the reason you have to bring this to the other side, sometimes you may not have a constant term here that goes to 0 after differentiation. So whatever you have there, bring it in. Okay, so we now have a function of x and y that looks like this. So what we now do, so dy dx will now be equal to minus function of x over function of y. What do I mean by minus function? The derivative of this function with respect to x, that is the f subscript x. The derivative of this function with respect to y is f subscript y. Okay, so now while you are differentiating x, y will be a constant. You treat y as constant. Okay, and while you are differentiating with respect to y, you treat x as constant. So let's say, so for this question now, what do we have? We have this is the function of x. Okay, we differentiate this with respect to x. Yeah, what do we that give you? 3x squared. Okay, this one is with respect to x now. It will be taken as constant. That is 0, right? Good. Now this with respect to x now. If you differentiate this x, that will just give you 1. So every other thing will be constant. Then that will mean you have 3 y squared, Abby. Okay. Then differentiating this one, that goes to 0, right? Now, don't forget that we have minus here waiting for us. So let's keep the minus here now. Let me erase this. So the minus is waiting. Okay. So I have this. Now divided by, so we want to differentiate this with respect to y now. This does not contain y. It will be taken as a constant. So differentiate that goes to 0. Then this contain y, right? That will give us 3y squared. This one also contains y. So we take 3x as constant. So that gives us, when you differentiate y squared, it now be 2, Abby. The 2 we now multiply this 3x. So we have 6x, Abby. So we now have plus 6xy, right? Then that constant still goes to 0. Okay? So if you look at what we have here, we can simplify to the previous answer that we have gotten. So this will now be equal to, look at the 3 is common, right? The factor is that we have minus 3, then we have x squared plus y squared over 3y squared plus 2xy. Okay, 3 takes out 3, and then we have to find that minus x squared plus y squared over y squared plus 2xy. Okay, so the previous answer that we obtained, you observe that we are having minus x squared minus y squared, meaning that we have multiplied through by minus 1. You understand? But here we just factor out the minus 1. Okay, so correction to the exercise. So yeah, recall what I asked you to do for the first one. So that means we can get a function f that look like this. Root x, y, right? Plus 3x minus exponential y. Are we good? So with this, don't forget that we can write this one as x raised to power 1 over 2, y raised to power 1 over 2, plus 3x minus exponential y. Okay, so we can now write our solution. The y, the x will be equals to minus, okay? So now we differentiate with respect to x, okay? So that means we're going to have 1 over 2, x is power minus 1 over 2, y is power 1 over 2, okay? Plus 3 minus 0 now, good, over, so this minus is for all of them, so that's why it's standing alone, okay? So over, now we differentiate with respect to y. So that will give us 1 over 2, x is power 1 over 2, y is power minus 1 over 2, okay? Then this becomes 0, and this will now become minus exponential y. Okay, so that's our solution. We just need to simplify, and that's all. Okay, I think what we now have here will be minus, okay, we have y over x root, right? Okay, so because this one will become 1 over x equal 1 over 2. Okay, so both of them will enjoy that power of half, and power of half is one, root. Okay, so don't forget this man here. This man is still waiting for us. So, all right, still waiting for us. But I'm looking for a way to take it off. So we are going to do that now. Plus 6. So I've taken LCM here. You understand now? I've taken LCM. So everything will now be over 2. Okay, but that over 2 will still disappear. So this will also become x over y square root. Beautiful, beautiful. Then minus 2 exponential y. So so that 2 that came down from this one, we are using to multiply this one. If you multiply this one goes off, then multiply this one. So that become minus. So we have it. Now we can make it beautiful because this one is having minus. We can bring this minus down to multiply what we have here so that we can write this one first before this one. So that we now have um, root y over x plus 6 divided by 2 exponential y minus root x over y. That makes sense. So let's do the second one. So our f in this case will be s cubed plus y cubed minus 4x squared y minus 3x squared. So that dy dx will now be, yeah, minus, then function of x. That will give us 3x squared. This is a constant, right? 0. Then this will become minus 8xy. Then here will become minus 6x divided by so now with respect to y, this one becomes 0. We now have 3y squared minus 4x squared. Then that also becomes 0. Okay. So now we are having minus and minus here. I can multiply the numerator by minus or decide to multiply the denominator by the minus. But you can't multiply both of them. You can either multiply the numerator by the minus or denominator by the minus. So that if it is numerator, it will become 6x plus 8xy minus 3x squared. I decided to write the positive one first. Look at this. This would have given us minus 3x squared plus 8xy plus 6x. So I decided to write the positive one first before the negative. So then it will now be over 3y squared minus 4x squared. Better still, you can multiply the denominator by that minus so that you have the numerator will remain the same 3x squared minus 8xy minus 6x divided by this one will now become 4x squared minus 3y squared. Beautiful. I love that. Thank you.